This is my project 2. I chose to do a classification problem. I chose the CDC diabetes indicators dataset to classify diabetes based on 21 different features. I found this dataset on the UCI Machine Learning Repository. Diabetes is a widespread problem. It affects hundreds of millions of people around the world. These are indicators of health, such as smoking, days physically active, etc. And they're basically lifestyle indicators on the health of a person. There were 21 of these indicators, and I'm about to show you all of them. So this data set was taken from the UCI Machine Learning Repository. It has 253,680 rows and 21 features. One thing that is unique about this data set is that all of the features are categorical or binary. So this came into play when I was choosing models to build. With over 250,000 rows, I was comfortable building all sorts of models. So I did a couple of steps for EDA. I wanted to look at the distribution of my classes and of my categorical variables. So here I can see that several classes are imbalanced. Among my binary variables, there are 14 binary variables. So this is a healthcare data set. I didn't want to do something like creating synthetic data or doing like oversampling or something. What I chose to do was this impacted my model selection. So I wanted to do tree-based models because I have heard that these are suitable for this type of unbalanced data, tree-based models and gradient boosted models. These are my categorical variables. They're all skewed. They have some outliers. I'm going to take care of that in my pre-processing steps. So here is my correlation matrix. You can see that I have a lot of, not a lot, but a couple of relationships which are strongly or moderately linear. You can see the dark blue and the dark red. I noted these relationships, but I didn't really do much with them. I wasn't worried about multicollinearity because I heard that that was something to do with linear-based models. Like if I was doing a logistic regression, the presence of these related variables kind of made me want to do tree-based models more. I also did the chi squared independence test with all of my target. The last two EDAs were mostly dealing with my features, but I wanted to see if there was anything, if I could relate my features to my target. So here, there is really one thing that was that really stood out. It was this one, the any healthcare column. It ended up having a non-significant p-value, 0.05 for 0.05 significance. So I could have dropped this column in my pre-processing, but I decided not to. I definitely could have, but I didn't want to. I wanted to keep it as original to the original data as possible. Okay, so I did two main pre-processing steps. I removed outliers from features that I noticed during the EDA. So in my box plot, I noticed these had a couple of outliers. I used IQR to knock these outliers out. I also did a stratified test strain split. So the reason I did this was my target was imbalanced. So I wanted to make sure that my training and my test set had like this imbalance present in it also. I thought a lot about doing encoding. There were many things for doing like one hot encoding, dummy variable encoding, all that, but all my categories are already integers, so I didn't think that I needed to do anything with that. Also, I am doing only tree-based and gradient models, gradient boosted models, so hopefully whatever skew or like imbalance I have in these classes or categories, these models should be able to handle that. This is pretty simple. Um, this is me training my models. LightGBM, XGBoost, random forest, and gradient boosted. Okay, so then I evaluated my models. I used three things. I used rock curves, I used accuracy scores, and I used F1 scoring. So uh, rock curves, uh, this is a common thing. It visualizes the performance of the classification model across all threshold values. So I'm seeing the two-dimensional area under these curves. We see that LightGBM and gradient boosting are performing the best here under this score, but XGBoost is close behind. Random forest performed the worst here, so that's something to note. Next, I did accuracy scores. These are all pretty similar. Uh, I Accuracy scores are important because it shows me that my model is effective. But in this context, accuracy scores were not used to evaluate or select my model. They're all pretty similar, and they were just used to see how well my models were doing. F1 score was something important. Uh, I did this because I had the class imbalance. So I created the F1 scores for each of these. Um, it seems like the XGBoost, random forest, and gradient boosted models, they had the best F1 scores. But I blended the models and re redid this. So model blending. So I wanted to see if I could create like a composite model with these things. Now, before I did this, I didn't know that I was supposed to use different types of models which worked with different distributions. This analysis, obviously, I did 3 gradient boosted models, and all of mine are tree-based models. So maybe this blending wasn't needed, but I wanted to try it out. I averaged them, and then I created a threshold for 0.5 for the classification. I got the rock, accuracy, and F1 scores for all of these, and then I compare them. So here is the table for comparison. You can see that they're all kind of similar in some ways. Uh, Definitely my worst performing, or some of my worst performing things were the random forest model. I had the lowest rock score, but had a decent F1 score. My blended model was interesting. It had a similar rock score, high accuracy, but it didn't have a great F1 score. Overall, I chose to do my XGBoost model. I had a good accuracy, but wasn't used to select the model. It had a high F1 score, which I think is important in the context of healthcare. F1 being the middle or the harmonic mean between precision and recall. You want to err on sort of a conservative side so you can correctly predict diabetes among enough patients, but you don't want to monitor so many patients that it's a waste of hospital resources. Overall, I think XGB Boost was my best model. Uh, this is my citation. If I were to do this project again, I would do hyperparameter tuning. I tried it out, but I couldn't figure it out. Um, Also, I would choose other types of models because this blended model was kind of useless. Um, Not useless, but I did all the same types of models. So I would do logistic regression, I would do SVM or something like that, and then try to blend the model and see what happens. Thank you for a great class. This is my presentation, Project 2, Diabetes Classification Model.